Hi all, now in this video we are going to talk about capability index, capability of a process. So what you mean when I say capability of a process? So capability of any process is extent to which this is able to meet its client specification. Now there are various ways using which we can study capability of a process. But one of the most commonly used ratio to study capability of a process is CP. Okay, and now in this video we'll be talking about CP only, what CP of a process is. So what is CP of a process? See, CP, speaking a bit non-technical, right? I would call CP as process potential index. As name suggests, what a process can do, what is the potential of a process, or say what is the maximum performance of a process on the given design. That will be called CP. In layman's language, I would say what is the 100% of your process, obviously on the same design. Okay, because when you change design, capability of your process changes. So I'm talking about on the given design, what is the maximum your process can do. Now speaking technically, we say CP is the capability of a process when mean of our process is centered on the target. Now let me explain what I mean when I say that. You can see here in this example there are three different possibilities. I have imagined three different possibilities, and as a matter of fact this is the only one machine, but I'm assuming three different scenarios wherein this machine is working for a client. This machine produces bottle caps whose specification is that it should have diameter of 2 cm, but variation of 1 mm is acceptable. That means any cap which has diameter between 1.9 cm and 2.1 cm will be accepted by the customer. Now see, you have three different possibilities. Now assume in picture A, I have assumed that my process mean lies somewhere around LSL. Okay, it's off the target. In process B, mean of my process lies exactly on the target, and in process C, mean of my process is again off the target, but at this now mean of my process is toward USL. Now let's compare all these three process. Rather than calling these all three as independent process, I've already said that this is the same process. I'm just assuming three different conditions under which these processes are working. So see, in process A, it's creating defect toward LSL. If you look at process A from USL perspective, this process is doing very good. But if you look at this process from LSL perspective, you can see there's good chunk of defect happening in this process. So if we talk about this process on an overall basis, we will say this process is producing defect. Now let's look at process C. In case of process C, though this process is not creating defect, but this process is prone to this process has good chance to create defect toward USL, because mean of process C is toward USL. From LSL perspective, this process is also good because mean of your process is far from LSL, so there is very less chance that this process will produce any defect toward LSL. But if you look at USL, right, there's a good chance that this process will be producing defect in future. Now let's look at process B. Now mean of process B is on the target. Okay, so if you see, the chances of defects are equal at both the specification. This is the only one scenario wherein the chances of defects will be equal for both LSL and USL. This state is called CP of a process, because even if mean of your process shifts even a little bit from mean toward LSL, then there will be good chance of defect, good chance that defect will be created toward LSL. Similarly, even if your process mean shifts a bit toward USL, then there will be good chance that defect can happen toward USL. So the bestest way for process to perform is when mean of a process is centered on the target. That is the reason we say CP is the capability of a process when mean of a process is centered on the target. Okay, so 100% of a process means a process is giving its 100% when mean of its process is centered on the target. Okay, now let's go to next slide. Now in this slide, what I'll do is I'll try to explain CP from its formula. The formula to calculate CP is USL minus LSL divided by 6 standard deviation. Okay, so let's try to understand what is USL minus LSL and what is 6 standard deviation. We all understand upper specification limit and lower specification limit are decided by our client, our customer. So should we call that acceptable limit, or say acceptable variation, or allowable variation? Because this is the variation that our client is allowing us, right? At the same time, now if you look at 6 standard deviation, then the question comes, what is 6 standard deviation? Now if you have gone through a normal distribution, if you have gone through video on normal distribution, I'm sure you will have idea that normal distribution says that if you go 3 standard deviation plus and 3 standard deviation minus from the mean, then almost 99.73% of the process will fall within that range. In statistical process control, we say that 6 standard deviation represent the normal variation of a process. Okay, so 6 standard deviation means normal variation, or say normal behavior, or say normal spread of a process. So should I call CP as ratio of allowable variation and normal variation? Just change of language, nothing else. Now if you look at CP as a ratio of allowable variation and normal variation, then it gives us idea how well normal variation of your process fits within your allowable variation. Normal variation means all the process is performing within that range, and allowable variation means all the process should function within this range. If any part of process functions outside that range, that means that is a defect. Okay, so now let's go to next slide. In this slide, I'll try to explain what CP tells us. What do you mean when I say CP is equal to 1, or CP is less than 1, or CP is greater than 1, right? So first situation, when CP of your process is smaller than 1. Now if you remember above formula, when can CP be smaller than 1? CP can only be smaller than 1 when your normal variation, that is this is the normal variation you can see, is greater than this allowable variation, right? Because see here, CP is nothing but ratio of allowable variation to normal variation. See, this is normal variation and this is allowable variation, LSL, USL. So when CP of your process is smaller than 1, that means normal variation of your process is greater than allowable variation, right? That means whenever normal variation of your process will be greater than allowable variation, that means some part of your process will be performing outside the specification range. See here, this is LSL, this is USL, and some portion of a process is performing outside LSL and some portion of process is performing outside USL. So what is the conclusion? So the conclusion is whenever CP of your process is less than 1, then that means your process by design is not able to meet its customer specification. That means even if your process works at its 100%, it will not be able to meet customer's expectation completely. It will just be able to meet customer's expectation partially. Okay, there will be defect in this process. Now let's talk about different situation wherein CP of a process is equal to 1. Okay, so now what I do is I work on variation of my process. Okay, I try to reduce variation in such a way that my normal variation now becomes equal to allowable variation. See here, the second picture, the second process. Here, the normal variation of my process is exactly equal to the allowable variation, right? That means, in this case, my process is not performing outside specification. But again, don't forget, CP means 100% of a process. That means 100% of my process is such that this will not create any defect. But if my process does not work on 100%, nothing can be saved. Okay, so this is when CP is equal to 1. When CP is equal to 1, then process is capable of meeting customer's expectation. Okay, now let's talk about different scenario when CP of your process is greater than 1. Now this can only happen when normal variation of your process will be way smaller than the allowable variation. You can see in process C. Now what we did was we worked on the process, we worked on variation, we reduced variation. Now the normal variation of my process is smaller than the allowable variation. That means in this case you can clearly see normal variation is smaller than allowable variation. Okay, so in this case your process is not creating any defect at this point in time. And see here, you have buffer. That means even if your process shifts from here to here, this will not create defect. You have space of making error. See here, this is the space that you have. This is the space that you have, unlike when CP was equal to 1. Okay, so whenever CP is greater than 1, this is the best design possible to have. That means your process by design is completely able to meet customers' expectation. Alright, so let me give you one layman's example to conclude what we studied in CP. Now, I'm sure you all play cricket, right? Cricket. So I'm giving you one layman's example. I hope that will help you in connecting CP in a real life scenario. But technically that might not be correct, right? But let me give you an example. Let's say you are playing cricket from, say, Mumbai Indians. Okay, and there's match going on between Mumbai Indian and Kolkata Knight Rider. Now you are batting, and say you have to score 36 runs to win the match. Now you have six balls in your hand. Now see here. This is a case wherein you have 6 balls, and if you work on your 100%, if you utilize those all 6 balls completely, then there is a possibility that you may win this match. CP is equal to 1. Okay? At the same time, say you just have 4 balls and you have to score 36 runs. Not possible. By design, you have lost the match. Third example, you have 15 balls and you just have to score 36 runs. You are in safer side. By design, you are able to hit those runs. Now, in reality, what happens, you never know. We are just talking about potential, what it can do. We are not talking about what it's doing, right? We are just talking about what it could do. So hope the session on CP was useful. Now go through our next video on CPK. Thank you.